Hello, my name is Carlos Zanini and I'm a professor from Federal University of Rio de Janeiro. I'll be presenting the work Variational Inference for Bayesian Bridge Regression with co-authors Hélio dos Santos Migon, also from UFRJ, and Ronaldo Dias from State University of Campinas. In Bayesian Bridge semi-parametric regression, we have a Gaussian likelihood for y in a regression form explained by covariates x and z, where z, gamma, represent unpenalized effect of covariates, where the covariates are z, while we have a penalized spline function of covariates represented by x beta. So we have it here and here. The penalization is taken as a bridge penalization, which includes alpha parameter. And for different choices of alpha, we have different types of penalization. For example, when alpha is equal to 2, we have the ridge, or we have the lasso when alpha is equal to 1, or we can even have non-convex penalizations when alpha is smaller than 1. Here's the Bayesian formulation, which assumes a Gaussian distribution for the likelihood, and for prior on beta, we have generalized Gaussian. And here is the other part of the prior, all supposed independent here. We propose using variational inference technique called automatic differentiation variational inference by Kuku-Kelber 2017. And the general objective of variational inference in Bayesian models is to find the member in a pre-specified family of variational distributions Q that is the closest to the target posterior distribution P of theta given y in terms of the KL divergence. So the ADVI transforms the original parameter space, which is restricted, into a new parameter called psi, which lies in Rd, in this case p plus 3, which has no restrictions. Now we can specify multivariate normals with full covariate matrix as the variational family for psi, which will imply full dependency structure on the original parameters theta. Here we can see, based on this simulation, that the results for the proposed methodology based on ADVI reaches to very similar results to the MCMC when we compare here the confidence bands for the B-spline knots, for the B-spline fit. And then here an illustration on real data shows for energy charges in northern of Brazil. And here is a snippet of the data, just a short part of it. And we see that results on the ADVI are very reasonable to predict the real points here. And the key point is that the proposed ADVI is much faster than the MCMC. It takes less than 14 minutes to reach 2,000 iterations, while the MCMC takes more than 19 hours. So the proposed approach is very fast, and it also gives similar results to MCMC, but much faster.